This industrial estate outside Reading holds part of the RACAL electronics group. Now we've come here to examine an important part of their computing. We're going to look at the data structure that they use to store information about the products they manufacture. But before we have a look at the computing, I asked John Edwards, their technical director, why they actually needed a computer.
It's simply a question of being able to access an enormous volume of information and being able to do it quickly. At present, our file holds information on up to 22,000 different parts, and these are used in different combinations and different quantities to build up our product range of about 400 equipments. The information must be very readily and quickly available to our buyers, who need to buy something like 400 to 2,000 different components in any one week, and also to our production people so that they can see when the parts are available and they can then start assembly.
In this Range Rover, we have the RACAL product that we're interested in. It's a two-way radio known by its product code 5080. Now what we're going to do in this television program is to look at how details of such a product can be stored in a data structure known as a tree. Now in order to do that, we really need to see how the product is manufactured. And for that, we need to go inside the factory. The factory employs around 100 people in assembling and testing products like the 5080 radio. Each stage of manufacture involves joining together partly assembled work from previous stages. The information about which parts combine at each stage is held in the computer, not just for the 5080, but for all of RACAL's 400 products. To understand which details must be recorded and how the structured information is held, we need to take a closer look at how a 5080 is built up. RACAL took a finished radio from the factory and stripped it down for us. The front panel contains a detachable control keyboard which fits into a panel containing connectors. That's a separate part of the whole radio which is designed for ease of maintenance with easily replaceable units. The power amplifier is another separate part which detaches completely. The central assembly is a chassis with 6 electronic modules, each of which can be removed and replaced in a matter of seconds. This one is the central control module. Inside the protective case are 2 linked printed circuit boards. And on the boards are many electronic components. It's these components, resistors, capacitors, integrated circuits, that RACAL buy in to start the assembly of a radio. We've selected one component, this resistor, code numbered 909841, to follow through the program. It's used in several places in the 5080 and in many of the other products as well. It's typical of the components that RACAL need to hold data about. It's relating these components to the completed radio that gives us a tree structure. The complete unit breaks down into 3 components: a power amplifier, a chassis, and a front panel. Each of these, in turn, is made up of sub-assemblies at a lower level. 6 separate modules make up the chassis. Each module contains 2 printed circuit boards, and each circuit board consists of many individual components. So this is a tree. It models the structure of a 5080 radio. We've only shown part of the tree. Each branch divides in the same way, and at each node we record how many of each component are used at that level. Starting at the bottom, we see which basic components come together at the very first stage. We asked the factory manager to describe how a 5080 began life. Dan Watkins.
This then is the first stage of assembly, and this is the printed board assembly which we manufacture at this stage. We use a drawing or a material list which is similar to this in all aspects, and at this stage it denotes the components and the value of each component. There are in fact 32 capacitors we fit at this stage. The young ladies use the circuit reference and the value of the component to fit to this stage.
Until the circuit board has passed through the flow soldering process, it's just a collection of loose parts. It's at the moment when the basic electronic components are soldered onto the printed circuit board that a collection of components at the lowest level becomes a sub-assembly at the next level up the tree. And the inspection of the soldered board is the first of RACAL's many quality checks on the complete radio. Each assembly stage is similar. Each corresponds to a level of the tree. Sub-assemblies like these circuit boards come together to make up higher level assemblies, control modules in this case, which in turn become sub-assemblies for still higher levels. That's moving up the tree. But at the bottom level, the first stage of manufacture, there are no sub-assemblies, only bought-in components. They come from the stores. When the storeman receives the factory's requisition for components, he won't be interested in the details of constructing a radio. He only needs to know which part numbers are required. The question is, are they in stock? And the answer has to be yes. Making sure that the stores hold enough components involves the tree structure and RACAL's computer. To explain how it happens, we asked the engineering services manager, Ray Bosher.
First indication we receive of the requirement for a 5080 is when we receive a piece of paper from our commercial department. The most important number on this piece of paper is the stock order, which is this number here. That is the cost centre that will follow the product right through its manufacturing life. We do in fact break this cost centre number down by adding another 3 digits to the end of it. Firstly, we have a quantity of parts that we wish to manufacture, and this, in this case, is 250 off. We have a brief description of the product just to identify it in detail. This is a transceiver, brief description, 20 to 80 megahertz VHF transceiver. From this information, one of the base files that we use is a parts number file. And this is a computer-generated file which in fact contains all of the information of all of the parts that our company has. We have currently about 22,000 items on this file, and I have an example here of this file. And here is the part number that we trailed earlier, 909841. It is a resistor, it is a 560 ohms value, has a 5% tolerance, and it is a metal oxide type. Here we have the suppliers from which we can buy this resistor, one being Electrosil and Welin, Dubilier and Erie. In fact, this part also has a NATO stocker number, so we have this identified in the catalogue also. Now what we need to know are the number of parts we require from this catalogue and how many of them.
The data about how many parts are required is built into the tree structure. RACAL want to make 250 radios. The quantities in the next level show that they need 250 amplifiers, 250 chassis and 250 front panels. That's 250 of each of the modules. and 250 of each printed circuit board. So to start manufacturing these circuit boards, they need 500 coils, 250 resistors, 250 integrated circuits, and so on. Now, RACAL can begin to compile their shopping list. This batch of radios is being charged to V226. Each module is costed separately, and the code for this one is 106. RACAL need 500 of this coil, part number 924802. 250 of our resistor 909841, 250 integrated circuits, and so on. These components will make up 250 printed circuit boards. To complete the module, RACAL need 250 of the other board, so the requirements there are added to the shopping list. That's for this module. There are also other modules and other assemblies in this product. And in any 1 week, the same process will be carried out for the whole range of products on the order book.
Of course, we don't just go out and buy these parts. The computer, in fact, gives us a printout called an SR16 that does give us a recommend to buy for all the items for any 1 week. This recommend to buy is a result of a batch computer run that will summarise all of the parts that we need in any 1 week across a lot of cost centres. This week's computer printout, in fact, gave us a requirement for a large quantity of part number 909841, our resistor.
This printout summarises RACAL's ordering procedure. The shopping list includes 250 of the resistor 909841, but since that doesn't allow for wastage, a safety margin is added. These requirements are then totalled for all the separate cost headings. This week, RACAL need 1250 resistors. But in the stock file, we can see a balance of 1025 free stock, the result of bulk purchasing perhaps, because you buy resistors in thousands, not one at a time. So, for our resistor this week, RACAL need an extra 225.
The recommend to buy also has another piece of information on it, and this is useful because we are a member of a group of companies, and in fact those other companies may be holding a free stock of these items that we wish to purchase. We have the ability therefore to go to those companies and ask them, can we have that free stock from them? For example, company code 47 have this same part number in their own free stock. They have a quantity here printed out as 500, and we can ask them for this stock prior to purchasing the quantity ourselves.
The remote terminal link from RACAL's central computer gives the buyer in charge the most up-to-date recommend to buy printout. The stocks held in other companies affect his buying decisions.
RACAL Seaton, can I have production control, please? Oh, hello, John. Bill Lancaster from Mobical here. I wonder if you can help me. We have a rather urgent requirement for resistor 909841. I need about 250 in a hurry, and you've got 500 as far as I can see from the SR16 in free stock. Is there any chance letting us have them from those on an intercompany transfer basis? That's good. You've got a vehicle coming up here this afternoon. Okay, if you'll raise the paperwork then, you know, very grateful for your help. Okay, John, thanks a lot. Bye.
The delivery of the basic components is just the first stage in building a 5080.
Thanks very much.
Once a radio is completed, it still has to undergo a battery of stringent tests. If the radio survives repeated shocks equivalent to 40G, it goes into the environmental test chamber. RACAL's equivalent of taking the radio from the steamy heat of the tropics to Arctic chill at 40 degrees below. And the final test, a thorough computerized checkout of every circuit in the radio. And the test readings form part of the documentation that stays with the radio throughout its working life. Now, if the radio passes all these stringent tests, then shipping the radio off to the customer is the last stage in the process. But not all RACAL's products stay the same. There are many reasons for change. For example, a new component could become available which is a lot cheaper than an existing component. So how do RACAL organise change?
Of course, any product will need to be changed at times, and for this we have a procedure called an engineering change note procedure. Now we have a typical example here for the 5080. This section of the change note here gives us the defect or problem, and in fact in this case we said the transceiver board output will not operate the harness relay. This meant that the resistor value was slightly wrong and the relay would not operate correctly. First of all, we need to get this change approved by a formal route so that everybody in the company is aware of it. We have here a capability of saying that we wish to change all product that we've ever made in the field if we have a very severe change.
Of course, not all changes are that severe. RACAL may wish to change finished goods in store, but not yet delivered, or only those still to be made.
But in each case, we have to amend the product information in the computer.
Amending the product information means changing the data structure. And in order for us to see how that happens, we need to see how this data structure is actually stored. Well, this data structure is the abstract data structure. It's the way that the RACAL management think about the radio and talk about the radio. But we're now interested in how it's actually stored in the computer. We're interested in the concrete data structure. We're interested in, for instance, how that is stored, or that, and how these links are organized. For each of these nodes, we have some data stored. One keyboard and one connector set make up one front panel. To the panel record, we add an extra field. A field containing a pointer, which leads us to the first component at the next level down. Every record has this pointer, pointing down the tree to the first component on the next level. But there's also a pointer across, from the keyboard assembly to the next one at the same level. Again, every record has this pointer. If there's nothing else at that level, we have a special pointer, the null pointer. So that's how this part of the structure is stored. To get from the front panel to the connector record, we need to follow the down pointer to the next level and the across pointer to the correct record. The computer uses these two pointers to represent this link in the abstract tree. Exactly the same technique is used for the whole tree. And every product is represented in exactly the same way. So that's how trees are stored. To find out how the information in them is changed, we need to know what sort of changes are likely. We asked one of RACAL's computer staff Bert Pitt.
A blanket change is one in which, for every occurrence of a particular part, wherever it is used, we replace it by another. An example of this might be in metrication, when we replace all imperial measurement fixings by metric fixings, wherever they're used in every product. And a local change, as we term it, is where in a particular product or set of products, we replace certain components only, but not in every use of that component, only in specific products. This might be where we're changing a fuse value or a resistor value just to satisfy specific conditions and not a universal condition. To make any sort of change to the product information, we make use of the parts number file. To the record for any part, such as the resistor 909841, we add an extra field. It's a pointer field, and it takes us to one of the product structures to a use of that resistor. This is the beginning of a chain that links all the uses of 909841 resistors together. Every record has got its tree pointers, but we're going to concentrate on a new pointer that takes us on to the next use of that component, which could be in the same product or in another product. Now, suppose we wish to make a local change. Here we use two 909841s, and we want to replace them by two of a new sort of resistor, 909842. First, we have to take care that the existing chain of resistors is not broken. We alter this pointer so that the chain bypasses a component, and then we can ignore this pointer. So the 909841 chain is still complete. But what about the new component? We may have used a 909842 elsewhere, so there will be a similar chain connecting every use of that resistor. We need to link into that chain. The changed components pointer is updated to link into the chain, and the pointer from the file is also updated to point at the new component. That's a local change, just one resistor being changed. Suppose we had a blanket change. We wanted to change every occurrence of a 909841 into a 909842. There is already a chain linking any 909842s together, and there's a null pointer at the end of this chain. To add on the 841s, we update this. We make it point at the head of the chain of 841s. Now, any search that starts from 909842 will find all of those resistors and those previously in the 909841 chain. And to finish off, we record the fact that there are now no 841s in any of RACAL's products.
That's how the concrete tree is amended. Now, a technically complex operation, like building a 5080, needs computer support. In particular, it needs the right choice of data structure. We've seen that this abstract tree can be used to represent the way RACAL see their products, and that this concrete tree structure is how it's implemented in the computer.
Is just setting out to produce his report. We'll follow him through all the important stages as he analyses the existing system and specifies the requirements for a new computerized one.
The first thing I did when I started on the clock department project was to sit back and gather my thoughts. I spent a day or so deciding how I should approach the study, planning what to do, deciding who I should talk to, and also collecting together a few details which I already knew about the clock department. I'd certainly have to look at the present procedures for stock handling. I'd have to study the clerical records kept in the clock department, and then I'd have to decide how a computer system would change the records and the procedures, what the benefits would be. There would be problems as well as benefits, and I'd have to consider those too. I'd have to talk to the clock buyer. There'd be other departments involved, like the audit department and the branches which receive the clocks, and I'd have to talk to them too. I decided to start with the clock buyer. I already knew that he was enthusiastic to replace as many of his manual procedures as possible.
Good. Now, what does that entail for our department?
Well, I shall need to come down and chat to you several times. I shall need to interview several members of your staff. And then I shall need to have a close look at all the stock handling procedures you've got in the department, particularly the deliveries from the suppliers, and also the consignments out to the branches. The other thing which I'll have to do is have a very close look at the clerical records that you keep in the department. You know, I'll have to determine what the function of each is. I'll have to see who originates them. So really, there's quite a lot of work for me to do, I think. But what I'd like to do to start with, because I think it's the most important part of the system, is have a good look at what you do when you send a consignment out to a branch.
Well, the best place to start would be in the warehouse,
Yeah.
where they're now pulling out orders ready for dispatch.
So this is an order form. I suppose it gives you the type of clock and the quantity.
That's correct. Now, she's just taking 3 of R161.
R161. Does that mean that the type of clock is indicated by a letter and a number?
That is correct, yes. The letter R in this case means it's a miniature alarm.
Yeah. And now she's writing the branch and the quantity onto the bin card.
Yes, that's right.
Very good. So this is where you write out the consignments, is it?
That's right.
Excuse me, can I ask you why you seem to be sorting them into some kind of sequence?
I'm putting them in order ready for the consignment notes.
Right. What's she actually writing down, Norman?
She's now preparing the consignment note. First of all, she identifies the consignment. This particular one looks as if it's for Birmingham.
Yeah.
Then she writes down the quantity, the catalogue number for each item.
Right, so I better make a few notes on that. At this stage, I'd learnt quite a lot about the clock department. There certainly seemed to be scope for replacing some of the manual procedures. We could save a lot of writing out by storing the descriptions and prices of clocks in the computer system. For my next meeting with the clock buyer, I had to start quantifying the facts I'd discovered.
Yes, I know about the investigation. What exactly do you want to know?
Well, Mr. Latter, what I need to do now is take some measurements of what goes on in your department, really. For a period of, say, a fortnight, I'd like all your ladies to record the times they take for certain tasks. And I've got these timing sheets here, which I'd like them to fill in for this. So what I mean is that whenever they start picking an order, I want them to write the start time down. As soon as they finish, I want them to write the time down. Whenever anyone starts writing out consignment notes, I'd like the time they start written down, then the time they finish recorded. And in all cases, the number of clocks that have been involved. By now, I'd decided that consignment notes were very important. I knew what information should be printed on the consignment note: quantity, code number, description and price. So I had to decide on the headings and what instructions should be shown. I also had to decide how many copies the consignment note should have and where each copy should go to. Then I could discuss the design with the other people involved. For example, the audit department. Audit clerks had to batch and control the consignment notes. So I sent a copy of the new consignment note to the internal audit manager, and I made an appointment to see him a few days later. So this is what the new consignment note will look like. This part is the receipt part, which will actually be sent back to you from the branches. If there's anything wrong with the consignment, details of shortages and surpluses will be shown here. Is that okay?
Is it possible for the consignment notes to be sequentially numbered by branch, so that if a consignment note is missing, we notice it immediately?
What you mean is... Let's have a look. So, you'd want a number here. Say I put 13 in there. what you're thinking is that the 13 means that this is the 13th consignment note that's gone to this branch so far this year. Well, I think we'll be able to do that, okay, because the computer will be able to work out the number each time before printing the consignment note. So it should be okay. As well as holding meetings with people at head office, I also had to make sure that the new system would be acceptable to the branches. Hello, Mr. Roberts. Nice to see you again.
Good afternoon. Nice to see you.
What I really want to do this afternoon is have a good look at what happens to the clocks when they actually come to the branch. Would that be possible?
Yes, if you'd like to come with me to the rear of the shop, the delivery van will be due any moment.
All right, I'll follow you.
This is the stock room, and the first thing we do is to unpack all the cases and check that we've received all the stock.
I can see how important it is that we get the clocks in the right sequence on the consignment note, because it makes the check-in so much easier. By now, several weeks after my first visit to the clock buyer, I was able to prepare a report of my analysis. I'd studied the existing records and procedures, and I knew what people wanted out of the new system, in the clock department, the other related departments, and the branches. Now I had to check the report with the data processing manager. I've got a copy of the draft report for the clock department. I wondered if you could have a good look through and tell me what you think about it, really.
Thank you very much, I will.
Not too thick, I don't think, is it?
No, that's fine.
I've also got a copy of the consignment note, as I think it'll look under the new computer system. I wonder if you could give me any comments on that as well.
Yes, I'll comment on that.
There's one problem, really. Under the present manual system, we use a yellow consignment note to indicate that the note belongs to the clock department, so it's immediately obvious it's no other department.
Well, I prefer not to use different coloured computer paper.
I wondered if we could use department number, perhaps a 9 somewhere.
Yes, perhaps we could have a large 9 over the whole of the consignment note.
One very big one?
Yes.
Oh.
Yes, that's the sort of thing I was thinking of.
Well, do you think you could let me have any comments on the report by Monday, preferably? Because the meeting is the next day.
Yes, certainly I'll do that.
Okay.
Thank you very much.
Thanks so much.
Thank you, Emily.
This meeting was really a milestone in my work. I'd completed the analysis and submitted a proposal. If the committee accepted my report, I'd have to go ahead and start to design the new system. And the clock buyer. What about savings? Well, we should certainly have a saving on data prep in the computer department, and similarly, in the branch audit department, there'll be a considerable saving on batching and controlling the consignment note documents. Well, those are the benefits. What about costs? Well, we'll need extra store for our main 2904 computer. We'll need a number of video terminals and hard copy printers. And finally, we'll need something that we call a terminal controller. So those are the areas in which we'll need to spend money on equipment. And you'll find more details about these in the report. So those are
Let's now pause and look at our story in terms of the diagram in your reference text. So far, we've been through these stages, with the difference that in this case, the terms of reference specified a combined initial and detailed feasibility study. And now, once Emlyn Evans gets the go-ahead, we come to the remaining stages. But remember that we're looking through the eyes of the systems analyst. We shan't see the programmer at work. Detailed design means designing inputs, outputs, files, and forms. The implementation has to be planned. Then it will involve training of staff, testing the new system, conversion of the files, and finally, going live. First, however, the decision.
Emlyn. Yeah. I've come from the Computer Development Committee meeting to tell you that the clock department system has been given the go-ahead.
Oh, that's tremendous news. That means I can get down to hard work on it now, then.
That's right. We must also look fairly soon at the selection of some terminal equipment for the system. And whoever it is, we must ensure there, as part of the contract, that we get some technical support from the suppliers.
I think we'll need a little anyway. Yeah. Technical support would certainly be needed later on, but before that I decided to prepare a system flowchart. The flowchart showed me how the different parts of the system were related and helped to structure the different tasks that were involved. I had to design the files which would be needed by various parts of the system. For instance, the catalogue file would be accessed at random using an index. And preparing program specifications was yet more paperwork. This program accepted and checked data from the input screens. For instance, looking at the branch screens, if there's something wrong with a branch, send back an error A. If another terminal is already processing this particular branch, send back error B. Error C indicates an error in order number. Most of the spec continues like that. But first, I worked on the screen layouts that the terminals would need. We decided to use ICL equipment, and their technical advisor was an expert on communications and screen design. I'll enter GO and we should get the branch screen out. Fine. What do you think of that?
It's certainly user-friendly, but how about the notification of errors? What system have you used on that? Did you use the system we discussed earlier?
Yeah, I've used a single alpha flashing code to indicate any kind of operator error.
Oh, well, maybe we could put some invalid data into those fields and we'll see how that looks.
Yeah, I'll enter a few fields. I'm not the fastest operator in the world. Is that okay?
Oh, yes, that's fine. That certainly handles the finger trouble element.
By the time I'd finished the design work, it was June. We hoped to get the system operational by September, so that it would be ready for the Christmas distribution period. As our deadline approached, we moved into the final phase of the operation, implementation. Training the staff in the clock department was an important part of this. Oh, good morning, everybody. What I want to do today is tell you a bit about this piece of equipment called a video terminal and explain to you exactly how you're going to use it under the new computer system. So, take the first group of clocks. You'll enter the catalogue numbers and quantities, send it off to the computer. If it doesn't like it, it'll tell you. You know, you might have entered a wrong catalogue number, or you might have got quantity wrong. You carry on like this, and when you get to the end of an order, what will happen is that the computer will sort the clocks into the sequence required for the consignment note, and then it'll print all the consignment notes out. So it's not so bad, is it? So I want a volunteer. And it's, don't be shy, it's nothing to be worried about. Are you going to have a go? Okay. Let's have a look. Right. Try entering catalogue number W123. Make it fairly slowly. Say as a quantity of, use the tab key to get to the next field. Says a quantity of 10 of this clock. But take this back one. It's all right. Enter 10. At the same time as training the operators in the clock department, we had to test all the computer programs to make sure that the system really worked. So I prepared some test data. This was a small amount of dummy information from which I could work out by hand what the output ought to be. Then the programmer and I compared the resulting output with my specification. Right, Ron, I've compared your output against what I expected you to get, and in fact it all looks very good. Apart from one thing. Yeah. You've got a total of 100 clocks on the order. I've got a total of 116. There's a difference of 16 floating around somewhere. Now, I've looked at each individual page, and they definitely add up to 116. So somewhere we're missing 16. Now, the only thing I can think of is when I entered the test data at the terminal, I entered 6 screens, and on the 6th and final screen, I entered a total of 16 clocks. So it appears to me that somehow that 16, which was on the last screen, has got lost. Don't know what you think from that.
Yeah, I think you're probably right. Do you want me to have a look at that?
Yeah, please, see if you can find anything. Yeah, it's probably something fairly straightforward.
Yeah. Yeah, it must be something to do with the handling of the final indicator, Emlyn. Yeah, there's the final page indicator. Yeah. It jumps around. Yeah, it's missing out this accumulator here, which adds into the page total.
Yeah.
If I move that back before the handling of that screen, it'll be okay.
Yeah, E indicates the final screen, so
yeah.
Well, it should be okay.
Yeah, I don't think there's much problem.
We also had to enter the real data for creating all the files. That took our data entry operators several days. Data for the catalogue file came from a printout of information stored in an existing system, with the descriptions and price changes added by hand. We checked the new files against the original data.
A154, £115, triple chime, oak, bent timer.
Yes.
A155, £89.95, single chime, bent timer.
Yes.
A157, £65, bim bam, strike, bent timer.
Yes.
A158, £119.95, triple chime, walnut.
Yes.
A159, £95, single chime, bent timer.
And although this was necessary in its own right, it helped us to spot something we'd all missed.
The prices for these clock batteries seem to be wrong.
Look, the price in the catalogue is 50p.
I know what's happened, Evelyn. We normally dispatch these batteries in packs of 2, so the price should be £1, not 50p.
We can change that, OK.
Now, is there anything else to do before we go live?
Not for you, I don't think, actually, but there's one thing I've still got to do. I must write out the operating instructions for the computer operations staff to run the system upstairs. And I've still got 1 or 2 other little bits of paperwork to do, but not much. So we should be OK to go live.
Good.
By now the system had been fully tested, but we were still a little apprehensive as the first order went through. Well, I think we're all ready to go now. Would you like to enter GO and get the branch screen out? Try again. Have another go. Just enter GO. Now enter the branch number, OK? Right, now you can start entering the catalogue numbers for the clocks.
Does the operator ever have to enter the selling price?
Not very often, no, just if the catalogue number isn't on file. Normally, she won't have to enter it.
So that's to cover new lines or
yes.
Omissions that were made. What happens at the end of an order?
At the end, what she'll do is check that the total quantity of clocks in the order agrees with the total quantity that she's got at the top of the screen. If they agree, all she's got to do is enter an E in that position, and the computer will sort the clocks, and with a bit of luck, printing will start.
It started printing very quickly.
Well, Norman, I don't think it'll print quite so quickly when all the terminals are working. It doesn't look too bad, does it?
No, it's very good.
Well, most of my job was now over, but there are 1 or 2 tasks that remained after the system went live. The most important one was to sort out and arrange all the system documentation. The main reason for doing this was to ensure that anyone who wanted to understand how the system operated would get a clear impression straight away from reading all the system folders that form part of the documentation. I kept a close eye on the system for its first 2 months of operation, and at the end of 6 months, we held a review to decide how the system was operating. One main problem came to light. This was that the terminal operators were making too many errors when they were inputting catalogue number and the quantity. What we did to correct this was to introduce something called a check digit on the end of the clock catalogue number. So we have a catalogue number here, V141, And what we did was add an extra digit on the end, in this case a 7, the check digit. Looking back on the project, it's proved a great success, and what it's done is given us a sound base from which we can computerise the remaining warehouse departments in the company.
You'll find the working of that check digit explained in the notes. It's a matter of history that this project was successful. But why? Well, basically because Emlyn Evans went about his work thoroughly and systematically. Thus, he first produced a complete list of things to do. Later on, he had full consultations with everyone involved. Then he designed his forms and screen inputs carefully with expert advice.
Let's say we've got a quantity of
He took good care that the staff were properly trained. All this meant that going live was enjoyable and successful.